Welcome back. Today we're moving on to section 1.6, talking about absolute value equations and inequalities. So our goal is to be able to write and solve equations and inequalities involving absolute values. Now, absolute value is something you've seen before, okay? So it's not a completely new concept. Basically, all it is the distance from zero on a number line, okay? And it always makes a non-negative answer, okay? So in numbers, what this means, the absolute value of 4, well, 4 is 4 away from 0 on the number line. Now, where it gets interesting though is when you're looking at negative values. So the absolute value of -4 is +4. It's still 4 away from 0, okay? So just when you're looking numerically, that's what you're talking about, okay? When you take the absolute value of a number, wipes off the sign, okay? Or symbolically, absolute value of x will be x as long as x is greater than or equal to 0. So basically x is positive. Or it's going to be the opposite of x when x is less than 0 because it's wiping off that sign. So now you're flipping it when you take it out. Okay? So an absolute value equation will have the variable inside the absolute value symbol. And these equations can have two answers, okay? Most will have two answers. So little caveat to this. Because absolute values always result in a positive value, you can never have one set equal to a negative number. So for example, this right here, if I give you that equation, absolute value of x plus 2 equals -5, you right away would say that that is no solution because you cannot set an absolute value to be equal to a negative number. All right, it doesn't work. So that's one exception. But let's talk about general. Okay, in general, how do we solve these things? Well, first, you want to isolate the absolute value, so AKA get it alone. Second, oh, I'm sorry, those are misnumbered. 2, 3, 4. I apologize about that. Second, you're going to rewrite as two equations, one positive, one negative. These do not have the absolute value sign anymore. Okay, you're rewriting it without the absolute value. Then solve each equation independently, and of course, you always want to check your solutions. All right, so let's put this into action, shall we? So our first example, the absolute value of 2x plus 5 equals 9, that already has the absolute value by itself. So I'm already set. Okay, so now let's move on to the second step. The second step says write two equations. One that's positive, so that 2x plus 5 could just be 9, or it could be -9, because once you would take the absolute value of it, that would make it +9. So that's why this always happens. You end up with two equations, a positive and a negative one, okay? And then you just solve them independently. So subtract 5 from both sides. Oh, I'm sorry, I wrote that poorly. And divide by 2. Here, subtract 5 and divide by 2. And so you're getting your two solutions, okay? So in general, that's what we're talking about, okay? Now, again, sometimes there's that added step of you have to get that out, the absolute value by itself first, okay? So when you're dealing with that, what that means is I'm going to add this 1 over first, divide by the 3, and now I'm going to separate it out into my two equations. The positive equation and the negative equation. So x could be 1 or x is -5. Remember, for the most part, we're talking about getting two solutions to these, okay? And again, just for a little bit extra practice, same thing here. Well, this one, that's a value is already by itself. So I'm just going to write the equations, the negative and the positive. So now subtract 2, divide by 3, subtract 2, divide by 3. And there you go. And again, the last one emphasizes that idea of isolating the absolute value first. So divide by the 2 now. Now you get your two equations, your positive equation and your negative equation. So you end up with -7 and -11. Okay? So again, just always be cognizant of the idea that when you can solve them, for the most part, you're looking for two solutions. All right, so another thing, you always want to check for extraneous solutions using the original equation. Now that comes into play when you get more complex ones, okay? So ones that look like this, okay? So when you get ones like this, you end up solving them exactly the same way, okay? You still get your two equations, your positive equation, and you get your negative equation. Okay, so even if there's more variables outside of the absolute value, still works exactly the same way. All right, so here I'm going to subtract 3x from both sides. Now I can subtract 5. So this half, I'm getting x is -3. Over here, I distribute the negative. This time I'm going to choose to add 4x to both sides. So I get 7x plus 2 equals -5. Subtract 2. So 7x equals -7. Divide by 7 to get -1. Now, in these ones, where the variable was both in and out of the absolute value, it becomes very important to go back and check our original equation, okay? And I'm going to check this side of it, okay? So let's start with a -3, okay? Let's see what happens when I plug in my -3. Well, -12 plus 5 is a -7. So this should be alarming to you, okay? When you plug it back in, that would be setting an absolute value equal to a negative number. And we've already established that we can't do that, okay? So what actually happens is when the variable is both in and out of the absolute value, it can create what's called extraneous solutions, a solution that doesn't work. The -3 does not solve the original equation because the absolute value cannot be set equal to a negative number, okay? It doesn't work. Now, let's check the -1 to see if that plays out well. Well, 4 times -1 plus 5, -4 plus 5 is a +1. So that one does check out, okay? That one is a plausible solution. But you just have to make sure that you're not introducing a negative for the absolute value to be set equal to, because that will not be right. So let's do one more example. Now I do need probably a little bit more space. So I'm going to erase over here to make sure that I have enough space to write my answer. So let's focus on this one now. So again, I'm going to set up my two equations, the positive and the negative. And now I'm going to solve them each. So minus 5x from both sides. So negative 2 equals 2x plus 14. Subtract 14, so I get negative 16 equals 2x. Divide by 2, so negative 8 equals x. All right, let's solve the other side. So 5x minus 2 equals a negative 7x minus 14. Going to add 7x this time. So 12x minus 2 equals negative 14. I'm going to add the 2 over. So 12x equals negative 12. Divide by 12 to get negative 1. Now again, this is that situation that I do want to be very, very careful. All right, let's go back and check what happens when I plug those in. So 7 times negative 8 plus 14. Okay, when I have that, that is going to end up giving me, let's see here, that's going to give me a negative 42. So again, I'm going to be having the absolute value of 5x minus 2, and it's going to be set equal to a negative number. You cannot end up with a negative number outside of the absolute value. Okay, so once again, that's going to rule out that answer. It's not going to work. Let's check this one. So 7 times negative 1 plus 14. So that's going to give me a positive 7. So that does work, okay? An absolute value can be set equal to a positive number. In fact, it should be. So that x equals negative 1, that is my only solution in this case, okay? The other one, the negative 8, is extraneous. All right. So again, quite a bit of good stuff in this lesson. So I do want you to take a minute here. I want you to write out your summary, recap what we talked about, anything that's interesting to you or any questions you have, and then come back ready to do your practice work.